Okay, so here's the first video that we're going to talk about U-sub. Just very, very big picture stuff here, just talking about what U-sub is supposed to do. Just like we've talked about before, derivatives and integrals, antiderivatives, I mean, are by definition opposites of each other. So if you have the derivative of a function, I know the derivative of ln x is 1 over x, that tells me that the integral, I'm using integral and antiderivative here interchangeably, because now we have FTC, and we know they're basically the same. The integral of 1 over x, I know, is ln x, plus c, obviously. So, if derivatives and integrals are opposites of each other, then all of the rules that you have for derivatives should also have opposites. You have chain rule, you have product rule, you have quotient rule. So the answer to that is not as obvious as it seems. Not all of your derivative rules have antiderivative rules that are just the opposite. This question is explored further in BC. Calc BC or Calc 2 or whatever it is. But the one we're going to look at is chain rule. U-sub is going to be undoing chain rule. Now, you'll learn in Calc 2, if you take it, or Calc BC in high school, you'll learn that there are sort of reverse rules for product and quotient rule. But not really. It only sometimes works. But that's for much, much, much later. We're going to be focusing on this. So, with that being said, let me delete this. So, if I have a derivative that uses the chain rule, I should be able to do an integral and reverse it. So let's just do the derivative first. We have the derivative of sine of ln x. Here I'm plugging in ln x into the sine function. I know I've got to take the derivative of sine and keep the inside, and then multiply by the derivative of the inside. It's not too hard. But I know from just knowing what an integral is that this should give me an integral rule. This integral, I just know right off the bat from what I just did, that this antiderivative is sine of ln x. So now the question is, how would I do this integral if this derivative problem weren't just given to me first? And the answer is U-sub. So, a U-sub undoes an antiderivative which you got from the chain rule. So, how do I see when to use U-sub? We're not going to talk about actually doing it. We're going to do a baby example like this, but we're not going to talk about actually doing it until the next couple of videos. So first, how do I see when to use it? Well, note that every chain rule derivative problem has multiplication. So there are two things that I see in this answer. I see a function ln x and its derivative, which is 1 over x. And I also see that derivative, which is 1 over x, multiplied by the rest of the function. So when I see an integral which has those two parts in it, that's how I know I need to do U-sub. So now, to do the integral of cosine ln x times 1 over x dx, what I do is I set my u equal to the original function. That original function from number 1 up here. The one whose derivative is there. Not the derivative. I don't let it be 1 over x. I let it be the original function whose derivative I also see. So here's how it works. I let u equal ln of x. I'm going to now take the derivative of both sides with respect to x. So u is a function, it's just the name of a function. So just like if y was ln x, I use dy dx to talk about the derivative. This is just the name of a function, just u. So I'm going to call the derivative du dx. Du dx is 1 over x. And now I'm going to multiply both sides by dx. These steps are the same for every single u sub problem. You do that every single time. And now I will transform this integral and plug in all of these pieces. So I have the integral. ln x I can just replace with u. This is going to go quick, so rewind and pause if you need to. Cosine of u, I'm going to underline the u. Cosine of u, and then 1 over x dx. What's 1 over x dx? That's just du, so I can just sub that in. So my 1 over x dx, I'm putting those in red. So now this integral is just an integral that I know how to do. It's just cosine. The antiderivative of cosine is sine of u, not sine of x. Add my plus c because I'm done integrating. And then I can just replace my u back in here. So I get sine of ln x plus c. And that's how you do it. In the next several videos, we're going to be doing more examples, and we're going to be talking about ways in which this can be different. And I'll see you in those.